Okay. Chapter 2 is solving equations. Don't worry, we can wait. So, solving equations. We start out simple and get more complex. It does not matter the level of mathematics you do. Solving equations is essentially the same all the way through. The only difference is it gets more complex the steps you have to make to do it. But the basic principles are always the same. You use an inverse operation. Okay, the inverse operation is an operation that undoes another operation. The inverse of addition is subtraction. The inverse of subtraction is addition. One undoes the other. Multiplication and division are inverse operations. The only difference between what you guys are doing here and what we'll be doing later on this semester and what my Algebra 2 kids do and my Calc kids do is it's more complex, the operations that they have to do. But the same basic principles are the same. Okay. So, the addition, subtraction, multiplication, and division property of equality says if I add or subtract or multiply or divide both sides of an equation by the same thing, they are still equal to each other. If I have two things that are equal and I add the same thing to both sides, the two sides are still equal. If I subtract the same thing from both sides, they're still equal. The key to solving equations is you can do whatever you want, as long as whatever you do to one side of the equal sign, you do to the other side of the equal sign as well. I can add 5 to this side as long as I add 5 to the other side as well. That's it. That's the big secret of solving algebraic equations. Is you do the same thing to both sides. Now, as you can see, 2, 1, these are solving one-step equations. So how many steps to solve? 1. And yes, I do need to see work. I do need to see work. If I don't see work, you're going to get marked wrong. Answers alone are inadequate. I don't care how easy you think it is. I don't care how much you know what the answer is without having to show the work. I don't care. Because sooner or later, it will get hard, and you will have to show the work. And if you don't practice it while it's easy, you won't be able to do it when it's hard. I've been teaching math for 20 years, and the same thing happens all the time. I get kids, oh, I can do this in my head. Why can't I just do it in my head? Because eventually you won't be able to do it in your head, and you'll start screwing it up. But if you show the work when it's easy and get in the habit of doing what you're supposed to do now, when things get harder, you'll have that work habit done correctly. Okay? I've been there myself. And at some point, you can no longer do things in your head. For some people, you may have already hit that wall and you have to do everything on paper. For other people, that may not happen for a while yet. For me, it wasn't for a long time that I couldn't do things in my head anymore. It's just who I am. Okay, there are things that I'm better at than you are, and there are things I'm sure that you're better at than I am. That's just life. Math is one of those things for me. Still had to do my work on paper because at some point you'll lose track of what you're doing. If you don't practice it when it's easy, you won't do it when it's hard. And you'll screw it up. Okay? I don't do it to be mean. I do it to make you better. Okay? I do it to make you gotta practice. Everybody practices. Okay? So, first set of examples. If I want to solve an equation, x plus 4 equals 2, I need to get rid of this plus 4. The idea is I want to get rid of it, so I do the opposite. The opposite of adding 4 is subtracting 4. And if I do it to one side of the equal sign, I have to do it to the other side of the equal sign. As long as I have this side, I took 4 away, If I don't take 4 away from the other side, I won't be equal anymore. I have to take 4 away from the other side to be equal. We want to maintain that equality. Think about it as a scale. We got one of those old balance scales. Okay, that's what we're doing. We're trying to keep it equal. If you take away 4 from one side, you got to take away 4 from the other. You're no longer in balance. Okay. On this one here, I have x divided by 3. The opposite of dividing by 3 is multiplying by 3. So I need to multiply both sides by 3. If I don't multiply both sides by 3, I'm no longer in balance. If I do it to one side and not the other, it doesn't work. Have to maintain balance. They're equal. To keep them equal, do the same thing. Okay? So, our first example problem. Okay? I want to solve x plus 3 equals 27. Without saying the answer, how many of you already know the answer? Figured it out without actually doing any work. Good. I'm happy. I'd love to see everybody's hand go up and have the right answer for that. But what do you still have to do anyways? Show your work. Okay. This is x plus 3. Remember, I want to get the x by itself. Our variables like to be by themselves. They like to be loners. Okay. Yes, ma'am. Sure, hang on just a second.
In trouble?
No, not this time.
Have you gotten in trouble before?
I have gotten called down to the principal's office before. My student teaching here. I got a note to go see the principal. Oh crap, what did I do? And you still, as an adult, and it wasn't like I was like fresh out of college. I had done some other things. I was like 30 years old. I still got a note to go see the principal. And oh crap, what did I do? It doesn't matter. He just wanted to talk about how I dealt with the student and kind of help me learn how to do better. It was kind of fun. Okay, so the opposite of adding 3 is?
Come up onto the board
No.
and do it.
Okay, what do I do?
Well, you subtract.
Subtract 3. Okay. Shh. Guys, so you subtract 3 from both sides. The plus 3 minus 3 cancel. I get x equals 27 minus 3 is 24. Notice how I do my work. This is how I want you to do your work. I want you to do your work like this. This is the correct method. Work vertically, not horizontally. There are good reasons for that. I had a student. She was a very bright young lady. Had her in pre-calculus. Very bright young lady. She was repeating it. She would come to me if they're at Miss Forrest, I got the wrong answer. What did I do wrong? Which is what you should do. You know, when you're doing homework, someone gets the wrong answer. She'd come to me and ask for help. And I couldn't follow what she was doing because she was working horizontally across the page. Now, I see students do that. I'll see students, they'll do this. They'll have x plus 3 equals 27, just like what we have here. And they'll go, oh, I subtract 3, and that's 24. That's not right. What you just did was say that x plus 3 equals 24. You did not say that x equals 24. You said that x plus 3 equals 27 minus 3, which is 24. So x plus 3 equals 24. That's wrong. That's wrong. That's why you don't work horizontally. That's where the biggest mistake comes from. Don't do that. It's no bueno. Okay, next one. X minus 4 equals 12. What's the opposite of subtracting 4?
Addition.
Adding 4. Add 4 to both sides. X equals 16. Easy peasy, right? Okay. Next one, negative 2m equals 36. So negative 2m means I have negative 2 times m. Remember, it's multiplication when you have a variable next to the number. What's opposite of multiplying? Dividing. So I divide both sides by negative 2. Watch your negatives. Your negatives 2's cancel. You get m. And 36 divided by -2 is going to be -18. X over 4 means what? X divided by 4. What's the opposite of division? Multiplication. So I multiply both sides by 4. Those cancel. I get X. -9 times 4. -36. This is how I want you to show your work. Exactly what I did here on your classwork that I'm going to give you in a little bit. That's what I want you to do. That's the work I want to see. Proper work means you're going to get things right. I like to see that. That way you know what you're doing. You know why you're multiplying. You know why you're dividing. Okay, you don't have to, but I definitely want to see everything else that's there. Okay. This one's a little tougher. Okay, but it gives you a hint. Solving using reciprocals. Okay, what is the reciprocal of 4/5?
5/4.
5/4. Flip it over. So what you do is when you have a fraction that is not 1/2 or 1 whatever, you multiply by the reciprocal. So I multiply by 5/4, which means I need to multiply by 5/4. If I do it to one side, I have to do it to the other. Now, when I do this, the 5s and the 4s cancel each other on this side, and I get m. How many m's do I actually have there? I have 1, right? Got 1 m. That's why we use the reciprocal to answer the next one, is to give it 1, to make it 1 in front. How many do I have? I have 1 of them. Equals. When you're multiplying fractions, okay, what do? You can cross cancel. 4 goes into 4 once. 4 goes into 28 7 times. 27 times 5 is 35. That's my answer. There, does that make you happier now?
Yes.
Good, because that's what I live for. Okay, so the question we have here, why would you multiply by the reciprocal? To make it 1, to get one factor, because that's why you multiply by the reciprocal. A number times its reciprocal gives you 1. That's the idea. So I want 1m, I want 1x, I want 1n, I want 1y, I want 1g, I want whatever one of that variable. That's what we want. We want one of those equals to whatever. To get 1, you multiply by the reciprocal. That's why we do that. Okay. So, word problems. I know everybody hates word problems, but word problems is where math hits reality. Okay. Although the ones you guys have are really kind of made up, they're really kind of useless, you know. But you do the best you can with the math you have here in front of you. So toucans and macaws are tropical birds. The average length of a toucan is about 2/3 the length of an average macaw. Toucans are about 24 inches long. And it says, first, right, what you're trying to do is you're trying to figure out how long the macaws are on average. So the first thing you have to do is write an equation as a model. So we want to write an equation, so there's going to be equals. Okay. So I have the macaws, and we use C because they tell us to use C right here in the diagram. C for the length of the macaw. And I want to compare that to the length of the toucan. Now, a toucan is 24, but they are not equal lengths. They're not the same. C is not 24, the macaw is not 24, the macaw is actually bigger. What is the comparison between the two? the toucan is about 2/3 the length of the average macaw. The toucan is 2/3 the length of the average macaw.
Just macaw like 36 inches.
I'm guessing. I haven't figured it out yet. But I'm using my algebra to make sure so I don't guess. Do the math and get it right. Yeah, get over it. You should see some of the handwriting I have to decipher.
It's mine's.
Okay. Yes. Which is what multiplying by 3/2 is. Yeah. Okay. So, have to set up the equation. The macaw is bigger than the toucan. The toucan is 2/3 the size. If you read the equation, the toucan is equals 2/3 the length of the macaw. 2/3 of. 2/3 means of, generally means times. 2/3 times the length of the macaw is the length of the toucan. To solve this problem, we need to multiply by the reciprocal. 3/2. Those cancel. So I get the length of the macaw is equal to, these reduce, 2 goes into 2 once, into 24 12 times. 12 times 3 is 36. And yes, I hope that in your head, some of you figured out, oh, it's 2/3 the length, it's got to be 36, or you figured that out some other way. That is besides the point, although that is a very good thing to be able to do. But you do need to be able to interpret a word problem, write down an equation, and solve it. You've got to be able to do that. You can't shortcut everything that's easy. Okay? There's a reason we start out with easy problems and work our way up. Okay? Practice the easy stuff. You got to do the fundamentals. Okay? You got to do the fundamentals. You've got to be able to do that. Every great musician, what do? They know the fundamentals. They practice, they practice, they practice. They work hard. Every great athlete does the same thing. Okay? Great authors. They write, they write, they write, they write. A lot of it ends up getting tossed out, but they write, they write, they write, they write. They practice, practice, and practice. They may end up throwing a bunch of it away before they ever print anything, but they practice it all the time. Same thing has to happen here. You've got to practice. And you've got to know your fundamentals. These are fundamentals before you can get to the harder stuff later. Okay?